is a blue planet, the only such planet in our solar system. Blue because it is bathed in water, and as such, it is the only known world to support life. Nearly 3/4 of the Earth is covered by one continuous body of salt water. The vast majority is too deep for light to penetrate. The ocean hides the majority of the globe from view. There is more unexplored terrain beneath the sea than there is on the surface of the moon. The ocean is so great in size, depth, and complexity that we have yet to fully understand its importance to the Earth or to ourselves. It is only in the past few decades that we have developed tools to see through the vast ocean blanket. Ocean researchers on the Oregon coast use sophisticated echo sounders to measure ocean depth. A powerful computer then processes the millions of separate depth measurements and creates a portrait of the ocean bottom. Just as a contour map of land displays mountains and valleys, these undersea maps reveal the shape of the deep ocean floor. Taken together, they give us our first highly detailed view of this portion of the Pacific Ocean floor.
Oh, yeah. Yeah, have a look at that. Pretty nice. I'll bet there are probably vents up and down this whole structure, both up into the north and through the crater and down to the south as well. Until very recently, we thought that the seafloor was basically a dull place, a flat, featureless, mud-covered plain. But in the past 30 years, and most particularly in the past very few years, through the advent of new technology, we find that the seafloor is quite the contrary. It's a very, very active, dynamic place where there are active submarine volcanoes and seafloor spreading centers.
We now know that there are chains of volcanoes stretching along the bottom of the world's ocean, forming the mid-ocean ridge. They are just part of a more extensive system of volcanic activity that circles the globe. The Hawaiian Islands began life as undersea volcanoes 30 million years ago. Eruptions continue today above the sea surface. Under heat and pressure from inside the Earth, lava pushes upward, adding new layers on top of old ones. Over millions of years, these eruptions have built the world's tallest mountains. Mauna Loa and Kilauea now stand nearly 9,000 meters above their base on the ocean floor. Sonar readings tell us that there are thousands of mountains beneath the surface of the sea, but until recently, few had ever been seen. Man's vehicles could not withstand the enormous pressures of the deep ocean. The space age changed all that. New metals and engineering techniques made possible construction of deep diving submersibles. Some can dive to 4,000 meters. Using these deep diving submersibles, oceanographers have made incredibly surprising discoveries. Everyone expected them to find undersea mountains and even active volcanoes, but no one expected them to find exotic new life forms. Yet there they were, 2,500 meters below the surface of the Pacific. White blind crabs, tiny shrimp, and large red-tipped tube worms, living in the dark, surrounded by toxic gases at volcanic hot springs. They were living under seemingly impossible conditions.
I can't see it at all. Oh, you can see it on the video now.
This was life without the energy of the sun, life without photosynthesis. It was life based on a totally different energy source. And that source, it turned out, was the heat of the Earth's interior. Rather than green plants converting solar energy to plant tissue, in this world, bacteria convert chemicals from inside the Earth, producing food for the hot springs animals.
Oh, beautiful. It's white smoke. It's white smoke. We have...
Scientists also found that some of these springs build chimneys from the dissolved minerals of the smoke.
I just say white. The other one's very soft. Can you pick some of this, please? Oh, sure. I can't see anything where I am.
These undersea hot springs and other volcanic activity may be responsible for the formation of the ocean itself. About 4 billion years ago, the hot rock of the planet was beginning to cool. And as it did, gases escaped from inside the Earth through countless vents. One of the gases was water vapor. Scientists think it rose into the sky, condensed, and formed rain clouds. Fresh water then rained back onto the surface of the Earth. Over millions of years, rainwater flooded portions of the land, creating the ocean. The ocean dominates our planet. Without it, there would probably be no life as we know it. Life probably began in the sea. Tiny plants and later animals evolved in the topmost layers of the sea, where sunlight penetrates and nutrients are plentiful. Most plankton, as they are called, are so small that scientists use an electron microscope to get a close-up view. In a vacuum chamber, the tiny specimens of plankton are first coated with a thin film of gold. The microscope bounces electrons off this gold plating. By reading the reflected electrons, the scope constructs an image of the plankton. There are two kinds of plankton. The animals are called zooplankton, and the plants are phytoplankton. Phytoplankton, like most land plants, produce oxygen, consume carbon dioxide, and build plant tissue. Zooplankton eat phytoplankton, and in turn, these strange-looking creatures are eaten by a great variety of sea life, from dense schools of tiny fish moving rhythmically through the rich waters close to the surface, to great baleen whales. These 35-ton giants can plow through plankton and schooling fish, mouths agape, scooping up 50 kilos of plankton in a single mouthful. Plankton support a complex web of ocean life, which extends from the largest of whales to tiny bottom-dwelling scavengers. The most productive areas of the ocean are near the coasts, and among these, submerged reefs are truly bountiful. The Great Barrier Reef off the northeast coast of Australia is the world's largest coral reef system. It is home to an incredible diversity of life. 1,500 species of fish, crabs, grasses, anemones, sea snakes, sharks, turtles, and hundreds of varieties of corals. The reef is like a forest. It provides cover, food, habitat. But the living coral that builds the reef is also an animal. Many corals have soft bodies, and like all corals, feed on plankton as it drifts by in the ocean currents. Corals with exterior skeletons are called hard corals. These are the reef builders. Only an experienced marine biologist should ever pick up or move a living coral.
What is it? Any guesses?
Sponge.
Okay. Now, would you believe this is an animal? We just picked up the skeleton of the mushroom coral a few minutes ago. What do we have here? The same skeleton with all the polyps, the tentacles out feeding.
The mushroom coral normally stings and eats tiny plankton, but it is capable of killing much larger prey. After killing a tiny reef fish, this coral will take nearly 30 minutes to slowly pull its meal into its mouth. Throughout much of the ocean, there is evidence of environmental stress. Many productive coral reefs have died. Fish populations have been over-harvested. Marshes have been filled. The problem is people. Half of the people in the world now live in coastal areas, and the number is growing. As the number of people increases, pressures on ocean resources mount. To understand what the future may hold, we need only look at the New York metropolitan area, a center of trade and commerce, home to nearly 18 million people. New York, like many other large metropolitan areas, sits on the edge of the ocean. In fact, much of New York stands on top of what used to be a coastal marsh. New York has filled in its wetlands as it has expanded. Where there are so many people concentrated on the water's edge, there is bound to be a waste disposal problem. Many coastal cities solve the problem by dumping wastes into the ocean. New York does a comparatively good job of handling its human wastes. Large treatment plants collect, treat, and disinfect them. The treated water is pumped directly into nearby rivers. The more concentrated waste, the sludge, is loaded into barges, shipped offshore, and dumped at sea.
3005.
The Coast Guard monitors the movement of these sludge barges through the harbor.
Okay, the Bay State's coming up on Cadell's West. The floor is east of
New York.
Shooters.
Security call, the motor tanker Exxon Connecticut is westbound at Port Ivory, bound for Billy.
Exxon Bay State, this is New York traffic. On the Conhook Range, Tubular is the motor vessel Oshead, your westbound destination unknown.
New York City's Department of Environmental Protection regularly tests and monitors the water to make sure that water conditions remain within permitted levels. New York works hard to monitor the disposal of its human wastes, but other wastes are harder to control. Toxic chemicals that come from factories, runoff from city streets, and nearby farmlands all reach New York's nearshore waters, polluting them. Marine pollution degrades some of our most productive coastal areas, including reefs, marshes, and bays. Discarded plastics have killed thousands of marine mammals. Chemical discharge has killed unknown numbers of fish and threatens the stability of plankton populations. Pollution is a serious global threat, one that requires more effective monitoring programs. As we affect the ocean, so the ocean affects all life on land. In combination with the atmosphere, the ocean creates our weather, including those powerful tropical storms, hurricanes. Since little can be done to stop a hurricane, the National Hurricane Center concentrates its efforts on predicting where it will go and helping people to get out of its way.
Good afternoon. This is Bob Sheets from the National Hurricane Center with the latest information on Hurricane Emily. Emily continues to strengthen, and warnings have now been extended over the entire island of Hispaniola. At noon, Atlantic Standard Time, Emily was centered near latitude 16.4 north, longitude 68.6 west, or about 170 miles south-southeast of Santo Domingo in the Dominican Republic.
And so I think that Jamaica probably will miss much of this. Now, this is not a point that's moving across. It has substantial area to it, you know. A hurricane is an aerial thing.
System, and it's, that's what makes it so dangerous. The winds.
That's correct. Based on our skill to forecast where this hurricane may go, and our forecast that we've issued for it, it has about a 1 chance in 20 or so of coming over this area.
Hurricanes have caused more loss of life in the United States than almost any other natural disaster. To minimize the loss, hurricane forecasters use airplanes to help them monitor the strength and condition of the storms. These planes carry some of the world's most advanced weather monitoring and satellite communications equipment into the eye of the storm. The information they gather will be relayed back to the Hurricane Forecasting Center. From there, it will be passed on to the public to warn them of the storm's strength and potential danger. Every minute counts. When a hurricane hits land, its winds may blow at more than 150 knots, enough to blow down buildings, overturn cars. A hurricane also drops torrents of rain, enough to cause heavy flooding. But the real punch of the hurricane, the part that kills, is often the storm surge, the gush of huge waves that comes in off the ocean as the hurricane hits. In its wake, the hurricane leaves twisted factories, broken communications, flattened crops, and shattered lives. Dramatic improvements in satellite, aircraft, and radar coverage of the ocean, coupled with new and more powerful computers, help researchers understand how a hurricane forms and how it moves. There is a direct link between the warmth of the ocean and the fury of the storm. Atlantic hurricanes form over the warm tropical ocean, usually in the late summer and early fall. At that time, trade winds blow across the ocean from east to west. The tropical seas heat the moving air, causing it to rise. As it rises, it carries aloft moisture from the sea. Rain clouds form. The rising air leaves behind a low-pressure area at the sea surface. More air rushes in and whirls upward as it, too, is heated by the sea and spun by the rotational forces of the earth. A number of small storms begin to sweep around a central eye, blending together to form a large hurricane. For as long as the storm remains over water, the hurricane continues to draw energy from the sea. But when the path of the storm takes it over land, the ocean energy source is cut off. The storm begins to die. Hurricanes draw excess heat from tropical seas and move it toward the cooler poles. This movement of heat is carried on all the time, less violently by winds and ocean currents. In this way, the ocean distributes heat more evenly across the globe and moderates the climate of the whole Earth. The ocean affects everyone, even those of us who live far inland. It helps stabilize the Earth's temperatures. Through evaporation and rainfall, it is the source of most of the Earth's fresh water. It provides us with foods, and it accommodates our wastes. How we treat this ocean will affect all life on this living planet.